Hello, the audience. Welcome to this session. My name is Mamadou, and I'm a PhD student at the University of Po in France. Today, I'm going to present to you our contribution related to the application of the Industry 4.0 paradigm to educational organizations by the concept of University 4.0. I start by introducing the purpose of our research. I talk about the context, problem statement, and challenges. Then I present the state of the art, University 4.0 model definition, autonomous learning architecture, and motivation scenario before closing with conclusions and perspectives. Let's start by an analogy between the different industrial and educational revolutions. On the industrial side, the first industrial revolution, Industry 1.0, is characterized by limited production with the use of the steam engine and the coal mining. On the educational side, we have the first educational revolution, Education 1.0, which is characterized by limited education for a few privileged people. The second industrial is marked by mass production with the use of oil and electricity as an energy source. The second educational revolution is characterized by massification of education with the democratization of access to education. The third industrial revolution is marked by the automation of tasks with the integration of electronics. The third education revolution is characterized by the integration of digital technologies as teaching and learning tools. Nowadays, we witness the advent of the fourth industrial revolution, which is based on a technological fusion of the borders between the physical and digital worlds to improve the management of product, businesses, processes, and services in the industry. Industry 4.0 is a shift from mass production or service provision to customized production focused on the individual requirements for each customer. The various industrial revolutions always lead to major changes in all activities of human life, especially in the field of education. This is the reason for the emergence of the first educational revolution called Education 4.0. According to some authors, Education 4.0 is a direct consequence of the Industry 4.0, which obliges educational organizations to prepare future generations of learners for the fourth industrial revolution. In short, a need to align education with Industry 4.0. According to other authors, Education 4.0 is a new paradigm that allows learners to be architects of their learning, characterized by the personalization of learning with flexible, dynamic, and adaptive learning pathways. With this second trend, Education 4.0 leads educational organizations to adopt new technological and pedagogical transformation to better meet the specific needs of each learner. The current context of education is characterized by permanent integration of technology with learning environments, with the use of learning management systems, digital workspaces, various communication tools, collaborative spaces, various pedagogical resources, and virtual learning environments. This learning model, increasingly supported by technology, promotes open education for a wide public with different profiles. Need to meet specific demands for each learner, continuous innovation in educational technologies and resources, and the adoption of new teaching and learning methods. In this context of large-scale education, characterized by an increasingly connected environment with a variety of learners of different profiles, it is difficult and resource-intensive to provide each learner with the personalized follow-up necessary to improve learning. Also, difficult to collect all traces of the learners, resulting in a low capacity for analysis and use of learning data. A lack of feedback to the teacher for the adaptation and the learning processes, and difficult to adapt resources and learning processes. So, based on this problematic, we summarize it in three main issues. We set the challenge for the problem of the personalization of mass education to enable educational organization to automate the management of learning processes by a system of autonomous management of the adaptation and differentiation of learning pathways. For the problem of analysis and the use of learning data, we set the challenge to enable educational organization to manage knowledge for the definition and execution of personalized learning processes by a specialized methodology and a generic framework for autonomous management systems. In relation to the problem of the acquisition of knowledge and skill by learner, our challenge is to promote an alliance between technology and human beings in the service of improving and adapting learning by scalable, maintainable, and dynamic model for better collaboration between the actors. Digitalization is changing everything. There are major digital revolutions promoting the development of new and innovative learning environments that are reshaping educational organization. Among these transformations are elements the use of computers, notebooks, smartphone and IoT, interactive contents, intelligent tutoring systems, tools for analyzing learning data, virtual teaching assistants, digital interaction, and automate assessment system. This technological innovation have promoted pedagogical transformation that are changing the way we teach and learn. Educational organizations are adopting new pedagogical approaches to facilitate access to educational contents and improve the quality of learning. These approaches include project-based learning, active pedagogy, blended learning, flipped classroom, and game-based learning. In the field of personalization and adaptation of learning, related work has been done using different approaches. CONTE proposed an automated system for adapting learners' learning paths according to the profiles of and pedagogical objectives set by the teacher based on genetic algorithms. Bezawi et al. Proposed a framework for personalization analysis in MOOCs, including a decision support tool on possible options for learning personalization based on ontology. Paquet et al. Proposed a method for calculating relation between competencies based on a structured competence model for adaptive learning and resource recommendation in MOOCs based on the semantic web. Santos et al. Proposed an adaptive e-learning system with a user-centered design methodology providing personalized learning by recommendations based on if-then rules. We compared these related works with our contribution based on certain criteria. Automation of learning processes and adaptation of the learning processes are supported in all works. Scalability with continuous integration of technologies is supported only in the works of Bezawi et al. And Paquet et al. Adaptation to dynamic and unpredictable changes in learning environments and autonomous process management are not part in these related works. With our contribution, we will propose an autonomous, scalable, and dynamic management system for the automation and adaptation of learning processes. Nowadays, despite the education 4.0 paradigm, there are barriers and obstacles in the transition or to the education 4.0, including difficulties in adapting to the individual and changing needs of learners and teachers, evolution towards highly connected universities, integrating people, robot, connected objects, and services to promote learning. Complexity and heterogeneity of the source of knowledge coming from teacher, physical books, enriched by the large quantity of multimedia resources on the internet. Lack of common semantics promoting intelligent collaboration and coordination between actors. Weak combination of technology and human beings in the service of adapting learning and differentiating learning paths. To contribute to the resolution of these problems, we propose the concept of the fourth university revolution, University 4.0, which aims to apply the Industry 4.0 paradigm in universities to promote the automation, adaptation, and personalization of learning processes. In addition to addressing the concerns of Education 4.0, University 4.0 brings to autonomous management of learning processes based on an integration of the physical and digital worlds in the service of improving and adapting learning. The architecture of the solution we propose is based on data sourced from the learning environments composed of a learning management system, learning object, virtual learning environments, as well as the interaction traces of the actors. After the collection and storage of learning data by using a learning record store, the data are intended for the customization systems constituted by the autonomous learning management based on the IBM MAPKey reference architecture of autonomic computing with the autonomous management modules run on an ontological knowledge base. Monitoring dedicated to the monitoring of the system, its properties, and its environment by collecting all kinds of information from the learning record score in order to detect symptoms. Analysis processes the information contained in the symptom, reserved according to the policy defined in the knowledge base. Planification develops action plan describing how the record changes will be implemented. Execution is to implement the plans by executing the actions in the form of recommendation to the teacher or the learner. To automate learning processes, it's necessary to have a description format for all entities that allows for reasoning on these descriptions. With the complexity of the actors in the learning environments, a sharp conceptualization leads to a formal explicit specification language that is understandable by humans and machines for better collaboration between people, between machine and machine, and between people and machine. It is for this reason that we have adopted the knowledge base with an ontology-oriented approach. The autonomous management of learning processes require a capable system implementing functions of descriptions in order to complete descriptions of actors, events, and changes. Dynamics descriptions identifying failures, problem in learning processes, prediction function capable of making a prediction about what will happen in the future, and prescription function to propose recommendation to the students or teacher. This is why we have adopted the IBM MAP key reference architecture from autonomic computing to provide a system with autonomous managed model, monitoring, analysis, planification, and execution. We work on a use case for distance learning course in cloud computing for a master's degree in computer science from University of Po in France. With a learning outcome-oriented approach set by the basis of Bloom taxonomy, we have already worked on the modeling of learning data source on the basis of a course model that allows a certain volume of learning traces to be generated. We have also set up learning data collection and storage system based on Learning Locker, which is an open source learning record store. We contribute to the transition to Education 4.0 by the concept of University 4.0, by applying the concept of the Industry 4.0 to educational organization for the automation and optimization of learning processes. In future works, we will improve the model of our data sources in order to achieve a final level of granularity of learning data before moving to the customization system. And we will publish the results of the solution deployed as part of the distance learning courses of a master's degree in computer science with 30 international students. Thanks the audience for your kind attention.